very good evening. So today, just a quick video about supercapacitor. So one of our friend asking about if we make a device supercapacitor, for example as a matrix supercapacitor or supercapattery, you have positive electrode, you have negative electrode, how to determine the mass. So normally what we did in our lab, we try to add the mass of positive electrode and the mass of negative electrode, we add together and divide by 2 to get the average mass. Because when you are doing a device, you combine positive and negative, the performance of the supercapacitor, supercapattery, or whatever your device is based on both electrode. So it is wise for you to get an average mass of both of electrode. For example, your positive is 0.005 milligram. So for example, your negative is 0.5 milligram, your negative is 0.8 milligram. So you combine the mass of positive and negative and divide by 2. Okay, so finish in terms of the mass, how to determine the mass of the electrode in order to calculate the specific capacitance of the device. So next, just now, so today my friend teach me actually how we can actually theoretically calculate the potential window of the device, because the examiner, the reviewer might ask something. They might ask how we can sure the compatibility between the charge of positive and also negative. For example, we said the device is capable to achieve 1.5 volt or 2.0 volt. So how actually we calculate that? So you can read from the journal, they have the formula. It's very easy formula. It's all about positive and negative electrode. When you combine together, so the formula is circulated between that device. So you should have the mass of positive electrode, that number 1. Number 2, the mass of negative electrode. So we cluster into A. So A, we should have both mass, positive and also negative. Secondly, you should have the specific capacitance of positive and also negative. Last but not least, what you're going to obtain is the potential window, which is the ratio between the potential window of positive and negative. So let's make an equation. So you can imagine, just imagine, imagine mathematically, you have in my left hand side here, you have the mass of positive electrode divided by the mass of negative electrode. So you have a value, for example 0.005 divided by 0.008. So the mass might be different. So you divide, you get a whole number. For example, 1.6 or 2, depend on your mass of both material. So equal to what? Equal to specific capacitance at positive divided by specific capacitance at negative times by potential window at positive divided by potential window at negative. So the key point here, we want to find the potential window ratio. The numerator is potential window at positive, denominator is potential window at negative. We want to know actually what is the maximum potential window that your device capable to achieve. So after you make a calculation, then for example you get 1.57, but that's theoretical, but during experiment you capable to achieve 1.6. Then you can validate your data. You can say that based on the calculation, it is able to achieve around 1.6. So you did the experiment and successfully to achieve 1.6 potential window. Okay, that's a little bit sharing today about how actually we can calculate the potential window of the device based on the calculation. I think that's all for video today. See you in the next video. Okay, bye. Have a good day.